Hello guys, good afternoon. You are welcome to my YouTube channel, the Explicit Tutorials. As you all know, my name is Tutor Joseph. In today's video, we are still discussing chapter 1 in Chem 111. Please, as you are watching this video, endeavor to subscribe, like, share, and comment. Now, this part, chapter 1, is not quite new to us. Now, if you understood isotopy, isobars, isoelectronics, mass number, neutron number, atomic number, electron number in your secondary school level, this wouldn't be any challenge to you. Now we are asked to look for the proton number and what neutron number, as well as what the ratio. This is what we are going to do. In our initial video, I told us that the proton number is same thing as what the atomic number and what electron number, and it's usually written as what as the subscript, while the mass number is written as what superscript. Now this first one, which is what helium, sorry, now helium, I have it to be 2 and what 4. Now the proton number here is already what 2. True or false? True. Now it's only for the neutron number of this guy. I told us that neutron number is mass number minus what proton number. It therefore means that neutron number is equals what 4 minus 2. In the initial video, I told us that we have the atomic number, proton number, or electron number is usually written as what subscript, which is 2. We have it to be what 2. All right. But the neutron number of an element is the mass number minus what proton number. So we now have this. Therefore, the neutron number is what 2. Okay. Therefore, to look for the mass number of an element, it is neutron number plus what proton number, as the case may be. Now, they said we should also look for the ratio of neutron to what proton. It becomes neutron to what proton. If neutron is 2, if the neutron number is 2, proton number is what 2. It therefore means 2 over 2, and this is what it means. It is 1 to ratio what 1. Okay, because 2 into 2 is 1, 2 into 2 is 1, so 1 to ratio what 1. It means that the proton neutron number to proton number is what 1. That is the answer. Then as for neo is Ne. Neo Ne, I have the atomic number as 10, mass number 20. Proton number, of course, is what 10. Is that not correct? Then the neutron number becomes 20 minus 10, and that is what 10. All right. To now look for the ratio of the neutron number to proton number, it becomes what 10 divided by 10. That is the neutron number, the proton number is equals what 10 divided by 10, and this is what 1 to ratio what 1. So all these these questions, they are the questions they added on after it's at the back of the topic after being what treated, like questions. You have about 15 or 20 questions thereabout. So I'm solving all the questions, okay? So take note of that. So what is the next one? Argon. I'm not going to be solving all for us. You solve some, and I will solve some. So I've solved 2 already. And let me solve for krypton. Krypton is, I have K arrow 84. I have 84 and what 36. Is that not correct? So now the proton number, of course, is what 36. All right. The neutron number is what 84 minus what 36. So 84 minus what 36. Take one from this, it put there, becomes 14. So 14 minus 6 is what 8. I'm left with what 7. So 7 minus this is what 4. Is that not correct? Yeah, it's correct. So I now have what 48. Which means that 84 minus 36 is what 48. Now to look for their ratio, you know that proton number is equals what the neutron number to ratio what proton number, that is n to ratio what p. This becomes If neutron number is 48 and proton number is what? 36. So what is their ratio? What can go into the both of them? Okay, I think 12 into this is 4. Then 12 into this is what? 3. Right? Therefore, the neutron number to proton number is equals what? 4 to ratio what? 3. So that is the answer. That is the answer. So at this point, to call it a day on this particular aspect, so you have to solve xenon and argon. Okay, the same procedure. Let me do for this. Argon is, I have a arrow, 1840. Proton number is what? 18. Right? Proton number is what? 18. Then the neutron number now is equals what? 40 minus 18, and that is what? 22. Is that not correct? Sure, 22. Now the neutron number now, so the proton number is equals what? 22 divided by what? 18. Okay, what can go into the both of them? 2, 10, 2, 9. All right, 2 into 11, 22 is 11. Then 2 into this is 9. Therefore, the ratio is what? 11 to ratio what? 9. So please take note of that. So at this point, we'll call it a day on this particular aspect. But the next thing we are going to be doing right now is how to look for the molar mass, the molar mass of a given compound. How do we look for the molar mass of a given compound? How do we do it? The molar mass of a given compound. Example 1. What is the molar mass of glucose? What is the molar mass of what? Glucose. Take carbon as 12, hydrogen as 1, and oxygen as what? 16. Okay. Now, in doing so, we are going to be adding everything together by what? Multiplication. Now, it means that if carbon is 12, it's going to be what? 12 times 6, which means 12 times 6 is 12 times 6 plus hydrogen is what? 12. So 12 times 1, 12 times 1 plus oxygen is what? 6. Therefore, now have 6 times what? 16. All right. So 12 times 6, that should be 65. 2 times 6, 12. 2 carry 1, 72. So I have 72 plus 12 plus 16 times 6. 16 times what? 6. 6 times 6 is what? 36. 6 carry what? 3. So that is what? 96. So you can see 12 times 6, 12 times 1, then 6 times what? 16, like that. Now, what do we now have as the answer? Sum everything together, that is 96 plus 76 plus what? 12. 6 plus 6 is what? 12 plus 2, 14. 4 carry what? 1. 1, put it here, becomes 10. So 10 plus this is what? 18. Therefore, the molar mass is what? 184. 184 gram. So this is what? The answer. Then example 2. Example 2. What is the molar mass of calcotiri? That is calcium triazo carbonate 4. Calcium triazo carbonate what? 4. What is the molar mass? Take carbon as, that is calcium as 40, carbon as 12, and oxygen as what? 16. The same thing. Calcium is 40, so 40 plus carbon is 12, 12 plus oxygen is what? 3, so 3 times 16. This becomes 4, okay. 40 plus 12 is what? 52. 52 plus what? 48. And that is what? 100 gram. So the molar mass of calco 3 is what? 100 gram. Now, normally for the molar mass of sulfur 4 oxide, the molar mass of sulfur oxide is what? Sulfur is 32. Sulfur is 32 plus oxygen is what? You have 2 here, and oxygen is what? 16. 16 times 2 is what? 32. I now have what? 64 gram. Which means that the molar mass of sulfur oxide is what? 64 gram. Just something like that. If I want to do for tetraoxide of a 6 acid, that is H2SO4, take H as 1, sulfur 32, then oxygen 16. The same procedure is also what? Required. Now it means 2 times 1, 2, and my sulfur is what? 32, plus, then oxygen is what? 4. 4 times 16, that should be 64. So this plus this is what? 34. 34 plus 64, that should be 98 what? Gram. So that is the answer. So I've come to the end of this part of chapter 1, Chem 111. So in my next class, we are going to be looking at how to calculate for the mole of a particular element or a compound, and the empirical molecular formula and molecular formula of a given compound. So at this point, we call it a day. Please, as you're watching this video, endeavor to subscribe, like, share, and comment. Now take this one as your own assignment. Look for the molar mass of the following compound. Look for the molar mass or the molecular mass of the following compound. I'll give you potassium heptaoxo dichromate 7, the molar mass of this compound. Then you also look for the molar mass of potassium manganese 4 7 oxide, then 3. You also look for the molar mass, molecular mass of I'll give you H2SO3. Then number 4, I have to look for the molecular mass of let me break it down. Calcium oxide. Okay, so this is your assignment. Solve it and drop the answer on the comment section. Do have a wonderful day.